No. Tandas the lucky. Okay, possible. No, why? So, go. Okay, fast one, fast one. So, water bottle. Okay, water bottle. Huh? Oh, thanks to the boys for giving out. Okay. Do you know the code? Know the code. Okay. Those who want to join can join. Okay. Tomorrow you're not around. Yeah. Oh. You're around. Yeah. Tomorrow. Around. What time is it? This one is yen. This one is yen. This one is Joshua, I think. Joshua or Aiden. You check. Okay, ready? Huh? Question? The question is under there. Okay. Oh, here, can Is it either one? Yeah. Either one. Okay. Oh, here, okay. How you feeling? Oh, okay. No. That's not scored already. Oh, obviously score. Oh. Ayo. It's normal lah. Is Sean back? Is Salihan back? Then who is this person? Archie. Archie? Archie. Where she should go toilet? Okay. Okay, don't worry. This one I go through you very easy one. It's a very chill topic. Ready? Yeah. Where are all the stars? So the worksheet that you get stars on it. Got stars. You notice that I got a new chalk for stars? Yeah. You notice that I got a new chalk for the stars?
Oh yeah.
Where's okay, never mind. Okay, can Okay, so I start. Okay, so I'll show you. Okay, go. Good. Okay. Let's play a game. Okay. Top two winners will get a Starbucks card. Okay, the first person to memorize 5 people's birthday and come back to me. Don't remember? Don't you remember?
You want me to
Now you know now, yeah. What you know? Now 10.
I can try.
Huh? No lah, cannot like that. If who already knows, then it's not fun.
I can try. I collected their birthdays for.
That is not fair already. Okay, ready? Except for you cannot play. Okay, ready? Okay, go. No. So we find it. Hey, cannot sit down. Cannot sit down. Sorry, I have to go. You go and find. Cannot, by 5.
I know.
So fast, eh?
Yeah, I got as well. 9 September, 5th October, 16 Jan, 15 Jan, 14 Jan.
No.
Okay, he's the banner.
Okay. Okay. Okay, I was okay. Five. You know 5, but Xingyu is same. Okay, Prabha and Xingyu are winner. Okay. Okay. So I want to ask Joshua, have you found out 3 birthdays? 2. Who are the 2? Archie, are you 6 March? Are you 6 March? You have to verify. No, Archie is not 6 March. Okay, so it's not counted. Okay, who's the other person? Yo Kai put what birthday? What's your birthday?
Oh!
Huh? Oh, okay. Kang Yu, when's your birthday? Have you found? Serious? Have you found anybody's birthday? Which other birthday have you found? When's Archie's birthday? January 14? Just serious. Open your eyes. Okay. Can I? Okay. I hope you're more awake now. Okay, so now I will start on increasing decreasing function. Can I? Okay, so increasing decreasing function basically is okay, this chapter okay, I think part 2, right? If I'm not wrong, I think part 2 or part 3. I think it's part 3. Part 3 should be on E and I. So you'll be on Thursday, E and I. Okay, so these 2 days we'll be going through power and part 2. It's very easy one. It's very easy one. So today, even if you slept for 2 hours, you are left with 5% of your brain, still very easy. Oh, okay? Can I? We see a decreasing function. So, as the word suggests, what is increasing and what is decreasing? Increasing means going up or down? Up. Decreasing is going up. Yeah, long. So if I look at increasing and the function is going up, what can you say about the gradient? Correct. So this one, the gradient is positive. Then here's decreasing, the gradient is negative. You see, very common sense. But what's the prerequisite is here, you are looking at inequalities. Your prerequisite is you need to know inequality because you'll be solving inequality. Because if your gradient function later is sine x, then you are looking at decreasing sine x less than 0. So increasing function, as the name, official definition, increasing, it means that for x between a and b, if x increase, y increase. Like this. Okay, so if you see a tangent, it's going upwards. Decreasing means if x increase, y decrease, means it's going down. Easy, right? Easy, right? Very chill, right? But let's be also more mathematically coherent. It has to be a continuous function. Okay, it has to be a continuous function. So one thing I find the function can add on is it has to be continuous. Otherwise, if there's an asymptote, then we cannot really say that it should be increasing. Okay? Then, now you just look at question 1.1. You can try it. Very chill. Very chill. Okay, so this one means member. X is a member of the real number set. X is a member of the real number. So this one means member. Member or element? Element. Example, Tyson member of the set 404. Okay, then example, Colleen. Colleen is double L. Colleen is a member of the set 404. Many years ago, I taught 404. I think their class t-shirt was the 404 not found. Huh? Jersey. Contractor. To the what? Vendor. Is it okay so far? You all know how to draw? This hand, your right line going up. Okay. So y equals to EX. If you use that small, you can take a look. Okay, no bickering. Okay. E power x looks like that. But if you look at 0.5 power x, it's going down. Remember, this is going upwards. This is going downwards. This is going upwards. This is going downwards. Okay. So in general, if you recall, y equals to a power x, right? If a is more than 1, the graph is in this manner. Okay? This is to help you for part B. Example, part B. Example, y equals to a power x. Who say the S word? Someone say the S word. You know what he call you? You know what thing he call you? He call you Joshy baby. So you better be careful. Don't go toilet with him. Okay, so next one. Yeah, I cannot say all this is proper in record. Okay, so y equals to 0.5. Okay, this is where a is between 0 and 1. A cannot be negative. If it's negative, it's a discontinuous graph. So if you remember all this from J3 line, when it's this 0.5x is the same, it is like same as 2 to the power of negative x. If you don't remember, so based on transformation, right, it is just reflection about the y-axis. If you don't recall, like 3 power x, 0.5x, it's just a reflection about the y-axis. Okay? Yeah. So then I go to E and F. Sorry, this is like similar to E, yeah. So if you look at C, y equals to log x. I hope you remember this is the similar to log ax, where a is more than 1. Remember the base is going up 1. It's going up 1. Don't need to stand. Sit down. You understand? Okay. Can I refresh your log graph? Okay, so log graph, this is the one. Basically, this line, the bottom line. Okay, so now the next one, y equals to log ax, where a is between 0 and 1. It will look like this. Okay? It will look like this, which is y, example, y equals to log 0.5x. This is like y equals to log 2x. Okay, so we focus on the base. Basically, the trend is if the base is more than 1, it's going up, it's increasing. If the base is less than 1, between 0 to 1, it's going down. Small base, going downwards. Big base, going upwards. Make sense? Can I? So, of course, going through all the exciting talk, I think you all deserve to see the answer now. Okay, so let's do them. Okay, we will not spend too much time on this example. I think it's ready for you to try. Those of you who are fast, can you just check your answer? Aiden, what did I say? You got draw or not? Stop talking to us. Huh? Last one is decreasing. Okay? Just remember, if the base is less than 1, it's going down. Now, these two are actually related. Oh, you remember? I mean, I couldn't resist the temptation to want to recap a bit now. Okay, log half x. Log half x. Why is it the same as? Can I say that this is the same as before? The same. Very good. Very good. Okay, so what is this? This is the same as log 2 power -1. This is the same as negative log 2. It's the same as negative 1. That's why this is the same as negative log 2x. So if you look at this graph, what are they? They are actually reflection in the x-axis. Can you see? Yeah. Actually they are not. They are different base. But in general, this and this. Okay? But this question they are not. One is non-base E, one is base. Okay. Now the next one. Y equals to 2 power x. Y equals to 2 power minus x, which is the same as half power x. You can see they are reflection in the y-axis. Y equals to 2 power x. Y equals to 2 power x. Okay. Yes. Look at the base. You basically look at the base. Logarithm, look at base. Base more than 1 going up. Base less than 1 going down. Exponential. Base more than 1 going up. Base less than 1 going down. Okay? Can I? Now give you all some more time to draw the graph. After you draw it, you can give yourself a star. When you are drawing, try to use pencil. Xavier, are you drawing? What are you drawing? Okay, look at the graph. Try to think. People to put an S. Oh. Why you so fast? Hey, hope we get stuck there longer. Wow, you stay up. Oh, you carry your baby, carry your baby chair. Stay up doing bicep. Good job. You. E. Half x is the same as 2 power negative. Okay, so I mean the way to remember the graph, of course, is just to plot out the points. Yeah. But if you look at half power and 2 power negative, if you recall transformation, they are like a reflection in the y-axis. They are like a reflection in the y-axis. Okay. Can Okay. Anyone still drawing graph? Don't need to take too long, just appreciate the graph. Yeah, the objective is, of course, not drawing graph. The objective is to know whether increasing or decreasing. Okay. Yeah, go on, okay? Okay, now we look at thinking time. So you see thinking time, right? Okay, when is log going up, increasing or decreasing? When is a power x increasing or decreasing? Is when we look at the base, right? So if you, what I said earlier, if the base is more than 1, the powers should up, the values. If the base is between 0 to 1, that is going down. Okay, ma? Can I? What about less than 0? Don't even talk business. Right? Base how can be less than 0? logarithm base cannot be decimal. Or, yeah. If you forgot, remember last time I teach you all this, y equals to -1 power x. Can we even do this kind of graph? Cannot, it will be -1, 1, -1, 1, -1. It's not a continuous graph. Okay? Use pencil, use pencil. Wow, look at you want like a Chinese calligraphy. It's like beautiful strokes of the paintbrush. Good job, Colin. Hope y'all got feel it now. Okay. Where is yeah. I will get to that in a while. Can you give me a second? Okay, then in a while. Wow, I like how you write short and sweet. Hey, write more lah, bro. Write so little. You're writing as fast as you're running. Okay. Wait, 1 second. Is there anyone? No. Okay. Good vibes only. See her iPad. Good vibes. Yeah. Which one? Quiz 2. It has not been decided. I'll get back to you. Yeah. Teachers to ask students. Teachers. See lah. Sometimes I ask, sometimes I don't ask. If your energy level high there. Okay. Okay, so I go on. So you all see, okay. What's the relation? Anyone see copies? Okay. So you see a relation, increasing and decreasing, right? Increasing function, the gradient is positive. Decreasing, the gradient. Oh, okay. Okay. So what will this bring to your memory? You will need to solve inequality. It could be quadratic, it could be trigo, right? It could be linear inequality. Okay. So now a definition, given an interval of x and a variable function, the gradient is positive, means it's increasing. Negative means it's decreasing. Now, if you see this, right? Okay, what does this refer to? Our children, you all see, okay. There's a bracket. It's not coordinate. It's not coordinate. This means member. This one means member. This one means between. Between A and B. Okay, it basically means x between A, x between B. Okay, whether you write like this or this, it's okay. Okay? Yeah? Yeah, but you understand this one, okay. Senior high especially, we use this symbol more. Okay, good question. Wow. Then I will write it in this way. This basically means x is between A and B. A square bracket is inclusive. Circle bracket, not inclusive. Just be careful, don't confuse with coordinates. Okay, Can hey, y'all two, Archie, Kate, keep talking, Okay. Hey, you so slow. Faster, you. I already go through. You see, even Sadhana scold you.
You said take photo, but you said don't take photos.
Huh? I never say don't take photo. I didn't. Hey, now I say don't take photo. Okay. Faster. Faster, please. Huh? Can I? Okay. Can I? Hey, so, what's going on? Okay. So, okay, now you try question 1.2, 1.3. Very easy one. It's so easy. You can even do it with one eye closed. Okay, so now to explain, some of you, I think Kang Yu was asking about question 1.3. Okay, so I'm going to get to that in a while. Even 1.2, sorry. Okay, so Kang Yu, I believe that over here, you should have found that your dy dx is negative x squared minus 3. Is that okay? Can Now, what am I trying to actually Kang Yu, this guy, right? What I'm trying to tell you is basically most of the time is negative. It's a negative function. What negative value function? Why? Because you see, x squared minus 3 squared basically is more than 0 for all x, but except negative square root 3 and square root 3. Because when x is at these two values, this, right, is equal to 0. Right? And if it's equal to 0, your poor dy dx is not going to be defined. Right? It cannot be. That's why they put this. Now, if I look at my numerator, right, is negative x squared. Look at this. It's so negative. Right? Negative x squared is guaranteed to be less than equal 0. Negative x squared minus 3 is confirmed. It's less than equal minus 3, which is less than 0. So if you look at your top right, or just look at your beautiful numerator, it is always a negative value. Your denominator, most of the time, is positive. Okay? Okay?
That's so good. Seems to be
No, cannot. What's negative? Wait. Wow, I think it's a very good question. Let me take a look. Aha, you've been tricked. Yes. Okay, what's the learning point? You cannot divide by 0. This is 3 divided by 1 and 6. Divide by 0 is undefined.
Oh.
You understand? Divide by 0 is undefined. That's why they put the limit square root 3 and 3. Square root 3. You see, so here this is the trick. This is how they out to get you. Okay? Can I? Okay, put a cancel. So if you look at the denominator, basically it's always more than 0. Right? Except for negative square root 3 and square root 3. If you look at the numerator is always negative, right? So the numerator is always negative. The denominator is always positive, except for these two values.
So that means you're always negative.
Always
negative.
Correct. Because the top is always a negative, the bottom is always a positive. So overall, it has to be less than 0. Can or not? Okay. So you all have time to try. Okay, after all that I've said, just for you to think. Okay, after all that I've said, just for you. So give it a try first. Try yourself before you copy. Okay? Can I? Micah, are you okay? You miss out something. Okay. Huh? Can. Yes, can. Hey, Joshua, pay attention. Where's your notes? Third time you never bring your notes this year. Better have your notes ready. You understand? Next time you don't have your notes, need to let the teacher know. I always go to a teacher, say, sorry, I never bring my notes this one. Yeah. Yeah. All got bring notes or not? Archie, pay attention. What are you doing? What is scratching your armpit? Huh? Okay. Ian, okay? Where are you at now? Okay. So now your numerator, right? Your numerator is always negative, right? Your denominator is always positive. Yeah, lor. But just take note, in this range, it cannot be negative or square root 3 or square root 3 because at these two values, right, this is going to be 0. Your denominator cannot be 0. If your denominator is 0, the function is not defined. Okay? Jialin, okay? Hey, Jialin, you haven't changed your shoe. Scam. Okay, later change, okay? Which answer? No. Okay. Huh? Huh? Yes, yes. So you can show that. Okay. Huh? 1.3 no need. So to show that it's increasing, right? The safer way is to define derivative. Show that the derivative is positive. So if you look at 1.2a, right? 1.2a is x squared. X squared guaranteed to be positive, not negative. X squared plus 1 confirm more than 0. So you can see that for all values of x, your gradient is always positive value, which means that it's an increasing function. Okay? And yeah. Anyone at 1.3? 1.3. Is 1.3 okay? Easy. Okay. So 1.3, there are many methods to do. You can either look at the derivative and solve inequality, or you can simply just look at the graph. Like what Sean is doing. He's looking at that space. Okay? By now, if it's possible, may I request that you should memorize your trigo graph already. Like I ask you to draw, I know what is sine graph. I know what's cosine graph. Yeah, you all will know it serves you very well when you memorize the graph. Okay? Yeah. Which question? 1.2. Part 1 or part 2? Part 2. Okay, so part 2, can I say that this is your dy dx? Okay, so you see, negative fat x for square root 3 x square root 3, right? Okay, let's look at the numerator first. I mean, the numerator, you can see that negative x squared in the first place is always less than 0. So negative x squared minus 3, guaranteed, is less than minus 3, which is less than 0 for sure. What I'm telling you is that Archie, today you look at a numerator, you know that basically it's guaranteed negative. Look at my denominator. My denominator is x squared minus 3 squared. This guy, anything that's square is guaranteed to be. Anything that's square guaranteed to be more than equal 0, right? More than 0 for all x, right? But we cannot have it to be 0. We want it to be non-zero. Am I right to say so? Right. It cannot be negative square root 3 and square root 3. And these two values is now become 0. Your denominator 0, you'll run into trouble. Is it okay? Because you see your denominator, this one cannot be 0, but we cannot divide by 0. Oh, yeah. So take note, cannot be 0, cannot be 0. Okay? Denominator cannot be 0. So, you see that the numerator is always negative. The denominator is always positive. Does that show you that all your function is always less than 0? It's a decreasing function. Can I, Archie? Oh! Oh, wow, now you can. Okay. Yeah, sorry. Which one? Where again? Sorry. This one is the same. Oh. To me, this part is not needed because, to me, this part is always more than 0. Okay, what are they doing from here to here? What are they doing from? They're reversing a solution. Solution to question. Because you know this will give you this, Archie. This will give you this. Correct? Yes, you're right. Okay, but don't need to because you actually don't need it. You actually don't need. Yeah. That's the issue with solution. Sometimes we depend. We look at it and it doesn't make sense. Okay, so I go on. I think most of you are doing pretty well. Are you okay? 1.3. Soft inequality. Hey, don't go backward next time. So this one, okay. Okay, again, I remember we go back to a definition of increase. Increasing is what? Positive gradient. So if I look at part B, gradient means what? Gradient means? Gradient means? No, gradient means what? When we talk about gradient, we are doing what? What topic is this? What chapter? Means what? We need to find the dy dx is 6x squared plus 6x minus 12. We need this to be increase is what we need. Yes, we need dy dx to be positive. Okay? Can I remember differentiation? Gradient. Gradient, differentiation. The two are like brothers. Okay? Can I? Yeah. So now see you will solve this. Okay, I hope you all are solving this. Solve right. Divide by 6. So what do you get after you divide by 6? Correct. Oh. Okay. Can. So this is the solution for. If you look at A part 1, anyone can tell me the answer? Want to give me a try? Marty, are you marking? Mark first. Okay. What's A part 1 answer? Kaisen, I look at you. You look like you did already. Part 1, A part 1. 1 by 2. Equal. Equal or not equal? Not equal. Both not equal. So your answer is x between pi over 2 to negative pi over 2. Is it correct? Okay. Correct. Part B, what about A part 2? What about part B? Negative pi to pi over 2 or
Negative 5. Negative 5. Negative 5. Negative 5.
negative pi to negative pi.
Then yeah, isn't it inclusive?
Wait. No. No, it will not be everything inclusive. I think it will only be inclusive at the left and the right. Okay, so why do I say that? Because let's say we draw the graph, right? Who did this by differentiation? Very good. Okay, so that's one way. That's one way. Okay, so let me show you how you can do part 1. Okay, so part 1, there are a lot of ways to do. Okay, one way is to just look at the graph. One way is just look at the graph. So if you look at the graph, right? Just now who was asking?
I get it. I get it.
Because this point are turning points. Okay, so negative pi. You can see that from here to here, the graph is increasing. The graph is increasing. So guys, look. Here to here is increasing. The one in green. But it does not include the 2 points themselves. Because at the 2 points, the gradients are 0. They're actually 0. They are what we call turning points. We're going to learn them soon on the later part. Okay. So you see here, what does this mean? Does it include? Circle means what? Doesn't include, It doesn't include. So the correct answer here, in case you don't like this way of notation, is the same as this. Okay? Circle means going. This one means member. Okay, so far, this is by using. Next part, you can see the one in pink. Pink color, pink color is this one. This means x between negative pi over 2 to negative pi over 2, or x more than pi over 2 to pi. Okay? Are you stuck in something? Okay, what happened? Calling breakout. Okay. The next. Okay. Okay, Start. This one need to use similar triangles. Yes. 2.3. So fast, Wait. You give me a while. Can I? Give me a while. Sir Kai Prava, give me a while. Let me teach the first. So what's another way to do? Is there another way to do? You can differentiate. So for example, I come back to the question, right? Sine x, my f prime max will be cosine x. So when is f prime max more than 0, right? Increasing means f prime max more than 0. Is cosine x more than 0. Where is cosine x more than 0? X between like pi over 2 to negative pi over 3. Because you remember cosine x, the graph looks like this. Right? From here to here. That's where it is more than 0. Okay? So this is 1.3. Is everyone all right? Are you all done? Yeah. 2.3. Yes. 2.3. Okay. Okay, so you are very fast, so I'm going to go on. Not in. Yes, yes, yes. Let me help the rest first. Oh, yeah. I always follow the slowest person as much as possible. Can I? At a reasonable pace. What question are you at? 2.3. Okay, I'm getting there soon. Give me about 10 minutes, I'll get there. Okay? Another 15 minutes, I'll get to 2.5. And then 2.6. But my favorite number is still 2.4.
Oh, no.
Okay. Okay, so now you look at thinking time. So, okay, guys, look at this one. If I change the constant term, but changing the constant term change the derivative? No. Because when we differentiate the constant, just this. Yes, the constant to 0. Oh, can I? Okay, can you just take some time to look at this? Basically, constant just does a particular translation. It does not affect the gradient. Okay. So if you are where am I now, can you just help me to focus, stay focused. Come on, don't daydream. Yeah. Page 5 of the notes. I will start on the connected rate of change very soon. To understand, I think for everyone. Oh, 1 second. Relax. Okay, 2.3, just remember you need 3 derivatives. One is given, one is hidden, one is the reward. Laura looking at people eat ice cream, she's very excited. So why do we use P? It's part of P in terms of P. So why I use so there are some unspoken rules now. For example, when you form your rate of change, sometimes you have sometimes your rate of change you just get still the R over P, right? I will write this as 1 over okay. Yeah, because let me ask you, dr dv, right? Versus dr, which one is easier? So I'll ask you, would you rather differentiate this? Or would you rather differentiate this? This one, right? So that's why dv dr b oh, okay. dr dt versus dr usually you will write this as the denominator. Here's the denominator. Okay. Yes.
Why is dv over dr equal to a? So is there any geometric connection?
No, don't have. Oh, it means sphere, huh? Yeah. It's a no, don't have. I think it's just a coincidence. Yeah. I actually don't know. Maybe you can Google. Maybe you can go. I actually don't answer. Yeah. But it's true. When you differentiate a sphere volume, it turns out to be the surface area. So I said, yeah. Getting that soon. Yeah. So remember, Joshua, are you okay? Put on the table and do. Put on the table and do so that I can see your work. Remember, find three derivatives, guys. Find three derivatives. Okay, one is given, one is hidden. Question 2.4. Here, question 2.4, you are given dV dt. That is 10 meter cube per second. Who's at 2.4? Okay, so 2.4, you are given dV dt. Right? What do they want? They want dr dt. What do you need? Who's hidden? dV dr. What is dV dr? Remember, volume is 4 over 3 pi r cubed. What is dV dr? 4 pi r squared. Right? At r equals to 5, is 4 pi 5 squared. So the answer is 20 pi. 20, wait, 100 pi. Okay? This is 100 pi, guys. dV is 100 pi. Okay, Aidan, you see? How many pi? 100. You how many pi? No, you are 50 pi. Okay, so next. Okay, now we look at this. dr dt is dV dr. Wrong. dV dt dr. So dr dt is dV dr divided by dV dt, which is 100 pi divided by 10. Or is it the other way around? Yeah, the other way around. So sorry. Okay. So yeah, 10 divided by 100 pi to give you 1 over 10 pi meter squared. Okay. Okay. Sometimes when you form this equation, okay, you see how I do it, right? Those who are 2.4, you may have trouble. Meaning, let's say if you got something like this one, okay, you want to find the dt, you have you'll be thinking of, okay, I want the r to be at the top, I want the t to be at the bottom, right? So of course the missing variable is dv. Then do we do the r dt or do we do dv dr? Which one is easier? dv dr. Okay, and this is easier. We always do dv dr. So I write it this way. Okay, ma? I write it as 1 over dv dr. It's easier to differentiate volume with respect to radius than radius with respect to volume. Or now take a look at, do you want to differentiate this or do you want to differentiate this? Yeah, this is so disgusting. Look at this. Are you look at this one? Nice, right? Cubic polynomial. So my two, right? Okay. Now who is at part 2 now? Some of you are doing. Who is interested to listen to part 2? Should I go on? Okay. So I thought about part 2. If you miss it, it's okay. Go back and watch the video. I'll repeat again tomorrow as well. Part 2 uses part 1 result. Now I know that a lot of you are those who are stuck. Did you go and do DVDA? I hope you never go do DVDA. Life is hard. You do DVDA. Okay. So then life is hard. Why not? Why don't you consider that, bro? Yeah, you're supposed to find the ADT, right? The reward is the ADT. Have you considered that the person that you are given is actually the RDT? Use this instead. Then who's the one that is hidden? D for part 2. One is even, one is hidden, one is the remote. This is the one that gets in the box. Who is hidden? DADR? Can or? DADR or? Okay. So how do I find DADR? My A is 4 pi r squared. We are talking about a sphere. DADR is 8 pi r. Okay. I'll let you all try the rest. Okay. I think the main breakthrough is you all must know that you are using DR. Okay, not DA. Yeah. Shh. Are you okay? Still alive? Okay, let me pause a while. Not alive.